So welcome everyone. So today we are going to handle the chemistry of period 3 elements. Yeah. And this is our very first lesson. So you all know, before we start any topic, I always take you through the course outline according to the syllabus book. And then we have our course outline, we have our lesson targets, and we make sure that we cover 70 to 90% of them, or even 100, and then we end the session. That's what we usually do. As simple as that. Yeah. Now, very fast, you can see we are behind as far as inorganic chemistry is concerned, but only for senior 5. Senior 6, we are sorted. Okay. Now, you can see senior 5, term 2, the very first topic, which is topic 4, is called periodicity 1. I introduced these things long time. So the very first topic is the periodic table. So if you have issues with the periodic table, someone may be like, what is really under the periodic table? So under the periodic table, this is what I mean. So if I mention anything that is giving you a time, you will have to go and revisit that work. Hope I'm loud enough and hope the screen is clearly visible. So you have the historical development and the organization, which is not high yield as far as exams are concerned, but they are good to know. Yes, have some knowledge about the historical development, have some knowledge about the organization, and yeah. So basically here I want you to learn the modern what? Periodic table. But all those things were taught. Um, Predicting trends. These are things that usually give people a time. Predicting the trends, so that reactivity based on element position, these things of atomic radius, ionic radius, personalization energy, first electron affinity, electronegativity, and electropositivity. So, and you all recall that the trends we looked at, 2 of them. We say that it is either down a group or across a period. And all these things were explained, yeah, under this very first subtopic of the periodic table. So if you have issues with any of that, I will advise you to go to the drive and check it out in your own free time. That's why we have free time on the timetable. I think you can see here, our timetable has that free time. That free time is for you to find when you can go through such things. Like tomorrow night you have personal reading. Even on Friday you have free time in the morning. You get such things. So you're supposed to use that free time well for such things. If at all you know somewhere I've mentioned, you do the needful. Okay. Now, I think you've seen the directions. Go to senior 5 term to work. The very first topic for periodic table, we have there 2 lessons. Yes, we have there 2 lessons. You should be aware. Okay. Just a minute. So I've told you that when you go to chemistry here, you go and of course it is senior 5. We have said term 2. I think you can see the very first topic 4. Have you seen the very first topic? It is periodicity 1. So under periodicity 1, that's where we have very first one, periodic table, which we handled, and I've said there are 2 lessons. You can see lesson 1 and lesson 2. So you visit them if you have issues. Watch at a very high speed. Always increase speed when you're revising. You can make it times 2, times 4, times 1.5, so that you cover very fast. Then the other thing we are covering next is period 3. That is subtopic 2. Then the other subtopic is group 2 elements, which we are also covering this very already. Then the remaining part of group 14 and group 17, you are all aware that we have that work. And that's how inorganic chemistry gets done by almost 50%. So, hope I've given you the sense of direction as far as periodicity 1 is concerned. I talked about periodicity 2 in that lesson of alkyl halides, the introduction, so I don't need to repeat that. And that's how inorganic chemistry gets done. So don't be surprised in your sample papers when you find these things of periodicity 1 and 2 being elements of construct. Yes. So that is it. I don't want to over delay there. So I'll go back to our book and see what we are supposed to know exactly as far as period 3 is concerned. So according to the syllabus book, the topic is called variation in trends of properties across period 3. You know why we are saying across, and we also add on diagonal relationships. Yes, we also add on diagonal relationships in the very same topic. So for today, I'm going to first maybe give you my own course outline, and then maybe we come back to this and maybe we compare. But this is all you're supposed to know in period 3. Yes, it is serious, but a lot of work was eliminated. And after all those, the next thing shall be group 2 elements. And that will of course be next time. And guess what? After that topic, the fifth topic is thermochemistry, which we also introduced those who studied with us. You know that those lessons are there. So there is a way we are going to cover this work slowly, and we shall converge the syllabus up to a point when 80% is done. So stay calm, trust the process, everything will happen. Okay, so we are going to see what we can cover today and maybe next time. We cannot just complete period 3 in just one lesson. That is very bad. That is very bad. I don't even support it. So we are going to basically use this. I gave it my time. I may not even waste time by rewriting, but just look at it. It's what I'm going to use. Yeah, we're going to just use this and see how things are going to be perused through and covered. So we begin. Okay. Now, to begin with, part A, they are talking of periodic properties. I want you to listen. Periodic physical properties of elements in the periodic table. And what is that? Melting point, atomic radius, ionic radius, first ionization energy, first electron affinity, electronegativity, electropositivity, and using data sets of periodic trends to analyze and graph this data to infer relationships and patterns, identifying exceptions and anomalies. Yeah, so the whole of this, I remember giving you an introduction, and I told you what they call periodic properties are these ones: the atomic radius, ionic radius, fascination energy. Then the study of how they are changing either across a period or down a group. That's what they call what? Periodicity. The properties are the periodic properties. How they vary is periodicity. So basically, this part A is looking at the periodic properties and their periodicity, nothing else. Then part B, they are talking about the physical properties of period 3 elements. And yeah, it's basically physical state. They are more or less like those of organic compounds. Physical state, melting points, structure in bonding, metallic character. I remember giving you metallic characters research in the first lesson of, no, it was the second lesson of the periodic table. So I believe whoever gave in their time and made research for that work, I even told you the books to use for research. So if you made it, this will be a walkover for you. You understand? These targets are going to be a bit disturbing for someone who has issues before, but we're going to have a very serious plan. So after us realizing that the very first one, So I was saying that we can now have our course outline. Then we are going to see how we can break down things. So the very first one, I'm not going to panic because we need an introduction that is very good. Before you even go to the periodic properties, we need to find out what are these elements we are dealing with? What are they? Yes. So for me, I actually believe that we are supposed to look at the list. Yes. Let's at least have the list of period 3 elements. Let's have the list of period 3 elements. And after having the list of period 3 elements, at least we can have their electronic configuration. We can have their atomic number. Of course, you know, it is electronic configuration that comes from atomic number. Yeah. So from atomic number, we can have their what? Electronic configuration. Some brief sort of introduction before we go into the periodicity and the sort. So I've said the atomic number will always give us the what? The electronic configuration. So after having that, we can now proceed with other things according to the syllabus book. Okay. Now, part B, we can now come and talk about, you are going to realize that before I teach you periodicity, you should be this kind of student who is aware of the structure and bonding. So bonding and structure is very important. Because for you to talk about melting point, you're supposed to talk about bonds being broken, isn't it? For you to melt something from a solid to a liquid, that means these bonds that are making the solid to be a solid must be broken and weakened so that it becomes a liquid. So before you even talk about physical properties or periodic properties like melting point and so on, I advise you talk about bonding and structure first, then the rest can follow. Because you all know factorization energy looks at removing an electron from somewhere, things which were explained very well under the periodic table, first subtopic under periodicity 1. So I advise that the next thing, the most important thing could be bonding and structure. I would really advise bonding and structure to come first. Yeah, bonding and structure. Bonding and structure can even help us predict the metallic character, as you're going to see. So bonding and structure. Then the other one, we can now talk about the periodic properties. I gave you the examples of periodic properties, and I told you how they vary across a period and down a group is what they call periodicity. So that's what I'm going to say. Periodic properties and their period what? And their periodicity. Hope you know what I mean there. So when you look at the syllabus book, it talked of periodic physical properties. So whatever. But bonding and structure will help us predict the rest. Now, after having those, you can now talk about the chemical properties or chemical reactions. Something like that. Something like that. And you people should thank God that in the previous curriculum, under period 3, we are looking at a lot of things. But your curriculum was so good that it said, for period 3, please and please teach only oxides and chlorides. Only. And it said, under those things, teach similar reactions. What are those similar reactions? They told us, please and please, teach reactions with what? Water. They told us, please teach reactions with dilute what? Dilute acids. They told us, please teach reactions with what? Alkalis. You understand? Oxides and chlorides, only those. Don't do other things. Only those. and make sure you cover similar reactions with water, dilute acids, and then with alkalis. Then after that, they went an extra mile and told us to cover the same concepts before we go into the chemical properties. What were those concepts? They told us, please and please, talk about the structure and bonding of the oxides. After, we talk about the structure and bonding of chlorides. After, teach the melting points of the oxides. Also teach the melting points of what? Chlorides. Chemistry is very hard. That's why it was just abridged. They just try to remove something. So I don't want you to force yourself and read other things outside what we are putting out. You will have a benefit of doubt because things will not be part of the syllabus. So don't be like, what if I go an extra mile and do other things? You may do a very big mistake and you may not like it. You understand? Yeah. So even the chemical properties of the elements, those have been chlorides and oxides. But even with the elements, they are here. Here they just mentioned sodium, magnesium, aluminium, and sulfur, but they put etc. That means that don't concentrate on only those four. Consider other elements. That's why our first lesson target is identifying a list of these elements. And the reactions were also similar. Still, they want us to look at the reactions with what? Water. Reactions with what? Dilute acids. Reactions with what? Alkalis. Things are not changing. Things are not changing. Yes. And then, before I go to the next thing, you've realized they have talked about what? Chemical reactions. So let me talk about them briefly, just to organize our course outline. So here, before I even bring in the chemical reactions, I can say other physical properties. You see, you need to understand what you need to know, so that you don't read the irrelevant work. So other physical properties, Iggy, you may be there and you want to literally know something about physical states. You may be there and you really want to know about solubility, you may need to know about density and so on, especially in group 2. Yes, in group 2, density was very important. And I have some good scenario about density. I think I'll share it with time. etc means that there are some others. Get the point? So after that, you have realized that the chemical reaction is stepped in, but they stepped in a very nice way. So this is what these people decided to do. So the elements, that is E, the oxides and chlorides, they are the only things they want us to do what? To know as far as period 3 is concerned. Elements, oxides, and chlorides. So all these three, I think people know where chlorides come from. If you attended with me last or the previous lesson of alkyl halides, we say they are called alkyl halides because of chloride, bromide, and iodide. That when chlorine reacts with any other element, what you form is the chloride. So for oxide, it is very clear. Maybe after a reaction with oxygen. Get the point? Now, for this case, they want us to react to these things. They want us to react all of them with three things. The first one being water. The second one being dilute what? These are the ones they want us to concentrate on. Then lastly, the alkalis. You people, this syllabus book is very fun. I know many of you have done work to do with concentrated acids, but me, I'm not going to give you that because I'm very sure that the syllabus book said what? Only and only dilute acids. And it was saying dilute acids and alkalis. So I'm not sure whether it meant both dilute and concentrated or only dilute for either cases. But alkalis, in most cases, it reacts as concentrated. So for alkalis, we shall have both. Because it just said dilute acids and alkalis. Maybe people who know good English can help us. When they say dilute alkalis, when they say reactions with water, dilute acids and alkalis, do they mean the alkalis are also dilute or they are on their own? In that we should consider both dilute and concentrated. Whatever. I've said in most of their reactions, they are They are concentrated. So that means concentration may not escape. So we just bring dilute just for just, as we are going to see. Hope that is clear. Whoever dodged the lessons of equations, chemical equations, a term 1 topic of senior 5, you're going to find issues with this part of reactions. You know, some of you are just bad at writing equations. They are not your thing. But one thing I advise, if you really feel like these things of equations are giving you a time, I request you go and revisit the work we did. I request you go and revisit the work we did on equations. It is senior 5 term 1 work. I don't know if you can see my screen. It is senior 5 term 1 work. It is here, term 1 work. I think it is under moles and equations. Are you seeing that third subtopic of chemical formula and equations? We have the first lesson which talks about only and only chemical formula. And trust me, we did a lot of chemical formula, whichever chemical formula you're going to find in these other topics. I really tried my level best and put it in that lesson, and we derived it together. Those who recall, it was at the beginning of the year. We tried our level best. Then lesson 2 was for chemical equations. I taught you how things are balanced, where I was just giving you the reactants and products. So some of the things we are familiar. So trust me, when you go back and revisit this work, then you try to come back and read these equations in period 3, group 2, and so on. You will not be finding a lot of hard time. They are long lessons, but please find time and read. Invest your time, enjoy senior 6. Okay, so to go back. So in case you start seeing stars as I write equations, I've given you a reference. And I've also told you the reason as to why you're going to be finding things hard. Okay. The other thing that is part of the course outline, that these two, the oxides and chlorides, we have been requested to talk about two things: the structure. We have been requested to talk about their structure. We have been requested to talk about their bonding, and we've been requested to talk about the melting what? We have been requested to talk about the melting point. Yes. Yeah. Been requested to talk about what? Their structure, their bonding, and their melting point. Like that. Both of them. Okay. Hope people saw that. So we are back. We are back. So the other thing you're not supposed to forget, that we are looking at this periodicity, this periodicity involves graph work. Yes. So you see some of our questions having graph work. So don't be surprised. Yeah, so the periodicity involves graph work. By graph work, I mean plotting. After plotting, you describe. After describing the shape of your curve or graph, you explain. Such. But a lot will come as we start revision, as we're explaining those things. Just stay tuned, stay calm, and trust the what? The process. So the very last thing under periodicity, in the previous curriculum, we used to talk about the qualitative analysis of all ions in period 3, most of them. But for your curriculum, thank God that they only want you to be in position to identify magnesium ions and also identify aluminium ions. what I may call distinguishing the two. Let me hope you are a student who can write the formula of the iron. All those things we are taught, I taught them in more concept. If you have issues with writing chemical formula, please go and visit those things. I even taught people how to write the bismuthate ion. So many ions, the plumbate 4, plumbate 2, I don't know if people can recall, but a lot of chemistry was there. And you people claimed that you understood. So make sure you have access to that work. Find all possible ways. Okay. Then lastly is diagonal relationships. These ones I may not do them today. Of course, we cannot complete all this work today. We're going to first just find a way we can cover it. Yeah. So the last one is diagonal relationships. So what is the end of this course outline? It ends on I. So from G we have H, and we have seen that H, it is magnesium ions written like that, versus aluminium ions, which are written like that. Then lastly, I is diagonal relationships. Diagonal relationships, and that is the end of the topic. Yeah. So I think now you people have what we call an overview. Now, when you people reach campus, that's where lectures stop. You bear me witness. This is what I've done. And lectures don't do much as I've done. But the moment they give you the course outline, they tell you the flow chart, the map. It's called the concept map of the topic. Now, what I've given you is the concept map. Now, this is where the lesson is actually supposed to stop. The rest of these things are supposed to be done by you. But at this level, sometimes we say it's okay, let's do work for them. But even at advanced level, you should be in position to just continue from where I've stopped. You can list the elements, you write the atomic numbers and configurations, say the bonds they have, their structures, periodic properties and their periodicity, other physical properties and so on, reactions and everything. You should be in position to do that. So that's our concept map for period 3 elements. You can take the screenshot. So we are now going to begin the real chemistry. Okay. Okay, I've been trying to go through the chart to see if there is any concern, but I think there is no serious concern. We can proceed. Okay, so with that, we shall have finished. So what is going to be the plan? What is going to be the plan? This is the plan. This is the plan. We are going to cover this part A. We are going to cover it. So I'll put a tick. We are going to do A. We are going to do B. Now, concerning the periodic properties and their periodicity, hey, these ones we are not going to study. Hey, we are not going to study. Because whatever I taught in the first lessons is what they are going to repeat. So I'll tell you what to do there. So the whole of C is going to be skipped because trust me, most of it is already there. What's not there is the graphical work, of which I also hinted on the graphical work. But as I've told you, graphical work is so nice in revision. We plot and then bring our theory in explanation of our shapes and nothing much. Yes. Then the physical properties, of course, I will hint on them. Then I'm interested in these reactions you're saying. I want us to do some of the reactions. Yes, I want us to do some of the reactions. I want us to do these reactions. Maybe we do elements. Yes, maybe we do elements. Then maybe next time we do oxides and chlorides. I don't know how the thing is going to move. But at least I want us to do some reactions before we leave this place. I want you to realize how easy they are. They are not hard. But these things of diagonal relationships are distinguishing magnesium and aluminium ions. Those ones cannot be for today. So our target is ranging in 50% of period 3. So that if you can have 2 lessons of it, it will be a very good move. Be a smart move. Okay. So So let's see the list of period 3 elements. So most of you have done a lot of paper ones in your schools, in your respective schools. You've done a lot of paper ones. And you know that in chemistry paper 1, they usually try their level best to provide the periodic tables. I don't know if people, I don't know. I don't know if people have seen the periodic table before. Yeah. So let me share my periodic table here so that people can have a look at it. Then I show you something. There is a name they usually use for the periodic table that people don't give time, and it is usually used. By the time you realize it is very late. Yeah, but that shouldn't bother you. So let me show you my periodic table on the screen. Let me search for it here. It's short period. Something, who is it? So if you're a chemistry student and you don't have your own, I really pity you. That's very bad. So I don't know. I don't know if you people are in position to see my screen. So that's my periodic table. I think we also used it in subtopic 1 when we are talking of the periodic table. We brought it out. We saw some elements. Even when we are writing electronic configurations, those we recall. I remember us doing something about it, isn't it? I don't know. You people, are you sure you can't see the periodic table? You people are just joking. Yeah, that's our periodic table, and it's the periodic table UNEB usually provides. It's what UNEB usually provides. So those who know the chemistry, you know that this is group 1, group 2, group 3, group 4, group 5, group 6, group 7, group 8. And I remember telling you how it is supposed to be written. I'm not going to go into that chemistry. Then you all know, so groups are the vertical ones. As you can see, 1 is vertical, 2 is vertical, 3 is vertical, 4 is vertical. 4 goes like that. That's why you are calling it vertical. Even 1 goes like that. That's why we call it vertical. Or they are called columns. So columns of the periodic table are the groups. Then these are the periods. The horizontal ones, or what they call the rows. These ones. So this one is period 1, this is period 2, this is period what? Period 3. So I think you can see. So period 3 is this one. Period 3 is this one. So when I ask for the elements and their atomic number, I don't want us to waste time. Yes, it is clear. Everything is clear here. Yes, that this is what? Sodium with atomic number 11. You all know the notation is X with those 2 letters, where X is the symbol, all this was told, where A is the atomic mass or mass number, and where Z is the atomic number of protons. Hope people know that. So you can see sodium atomic number 11, magnesium 12, like that. I also tried to hint on these values when I was explaining the trend, I think, for atomic radius. The symbols are very clear. Sodium Na and so on and so forth. Configurations, those ones I taught. If you have issues with configuration, for you just go and watch those videos. They're also there. I think it's a term one topic, I think. Go to the drive senior 5 term 1 work, go and watch. If at all you have issues with configuration, I may not re-explain. So as topics become worse and worse, there are things I will not repeat. You all know I never repeat myself. That's why I record this work. So that you don't call me a bad tutor. Okay. So when I come here about the list, we are going to refer to our document. So I came with the document today to save time. In most cases, you realize that chemistry I use notes. Because if I'm to write on my own, we may delay unnecessarily. So for chemistry, I always come with the book once in a while. But for math, in most cases, we do the concept and do a lot of examples like that. So we are going to refer to our book. We're going to refer to a certain book I came with today as we follow our course outline. Yes. Okay. So this is it. So the heading is elements in the what? In the third short period, what you can call period 3. Third short period. So you can see third period. Someone may be like, but why are they calling it short? If you look at this periodic table, you realize there is this space here. I think this space in brown, this one. But for these other ones, this space is filled with elements, you understand? So this one for period 3, it is a space, but these other periods down, they are filled with elements. So it makes the upper ones short. So the upper ones are short periods, these ones down are longer periods. Because where the first ones have spaces, these ones have their elements. So the word short should not be a concern. Third for period 3. Hope that has been talked about. So here we are having the element, here we are having the atomic number and the configuration. So I've told you for configuration, in case you have any issues, I'm not re-explaining, you simply refer what? To the drive. Simply refer to the what? To the drive. The elements I've told you, you refer to what? The periodic table. To see the symbols. Atomic number, you also refer to what? To the periodic table. And the list will be done. Yes. So you can even see the order. So don't be like, didn't they leave any element? They never. Because this is 11, 12, 13, 14, 15, 16, 17, 18. And you know it goes from sodium to argon, as you can see there. I think you can see from sodium right away to what? To argon. So nothing has been left out. Argon right away from sodium. So all of them are there. Yeah. So concerning the list of period 3, everything, I'll put a tick. So we have started moving. Yes, that is our first achievement. The list, the atomic number, elements, their configuration, we are done. So now the next thing is us talking about their bonding and structure. So you people, I don't know if you attended the lesson of compounds. There is when I taught compounds, it was still under mole concept. But here I'm going to pardon you people, and I slightly talk about it, but I'll never. This is going to be my last time. It's going to be my last time. It's going to be my last time. Hey, Let's agree about that. So, let's see something about the structure before you even go an extra mile. Yes, before you even go an extra mile to draw funny structures or to go through our book. So part B, it demanded bonding and what? Bonding and structure. And trust me, you people, if we do bonding and structure, the periodicity becomes very easy. The periodicity becomes very easy. So bonding and what? Bonding and structure. What is demanded here? I want us to go element per element. Ariho, leave our screen. Thank you. Okay. Now, what you people need to know about this thing of bonding and structure, it is very easy. Have it in mind that in chemistry, we have what we call metals. In chemistry, we have what we call nonmetals. You get the point? This is broadly. Someone may be like, but what of the semi-metals, the metalloids? They're also there, but I'm talking of broadly. Broadly, there are two. You're either a metal or a non-metal. Even when you're a semi-metal metalloid, you may have more metallic properties than non-metallic properties, so that one makes you a metal. You may be a semi-metal metalloid, but when you have more non-metallic properties than the metallic properties, so that makes you a non-metal. That's why I'm saying broadly we have those two. I want you to listen carefully, carefully, carefully. You get the point? Now, what is funny is this. What is funny is this. These metals, when you're having a metal here and a metal here, when these two are bonded together like that, this one is what they call a metallic bond. Are we together? This one is what they call a what? That's what they call a metallic bond. Are you following? Metal bonded to a metal. That's why they call a metallic bond. What if what if we want a complex structure? Yes. What if we want a complex structure? The metal atoms. Yes. Like you're having this, your metal here, having your metal here, you get? Having your metal here, your metal there, having your metal there, having your metal there. Like that. You're having your metal there. What really happens? I want to show something here. I want you people to look at this. You listen. You listen. I've talked of the metal and metal, then I've talked of metallic bond. Oh, you look at this. Remember, what I'm going to put here, no student knows it in the country. You're also going to learn it from me and you've never heard of it. And if any of you has ever, you please be genuine and tell me that half of me have ever heard of that. because for me I also learned it, I think 2 years back. I want you to remember that metals usually lose electrons and form positive ions. This one, you know it. All of you know that. I explained it. Yes, that when metals or metal atoms lose electrons, what do they form? Positive ions. Remember telling you that very well. And you all know the equation. I even talked about it in ionization energy. That you'll have your metal like that. So M for metal, eh? So I'm going to be using letter M for metal, and then Nm maybe non-metals. So you're having your metal there. Remember telling you about gaseous. So what happens when it loses electrons? It forms positive ions. I want you to listen. I want you to listen. Carefully. Carefully. The ion it has formed is a what? A positive. And the electron, or the electrons being lost are negative. So you like it or not, these two will be attracted. You know if people are getting me. I don't know if people are getting me. So this one is what they call the positive ion. The positive ion of the what? Of the metal. Then this is the electron cloud. And you all know it is negative, because you know electrons carry a negative charge, you get. Now, the ion the metal has formed is a positive, isn't it? And the electron cloud of the metal carries negative charges. So these two can attract. Yes, can attract. Unfortunately. Yes, the electron cloud has been lost, but it is somewhere there near. And the ion has also been successfully what? Formed. So you're having M with a plus, and you're having this. So there is this force of attraction. Yes, there is that force of attraction. So this force of attraction this force of attraction is the metallic bond. Is the metallic bond. So who is that genuine student who assures me that, doctor, for me I knew that is the structure of the metallic bond? Who is sure that you really knew that a metallic bond is that one between? I want you to be genuine and tell me the fact that, doctor, for me I knew that a metallic bond is that one between the positive ion the metal forms and its electron cloud. Why is that attraction existing? They are oppositely charged. One is positive, the other is negative, so they can literally attract. So that force of attraction between those two is actually a metallic bond. Leave alone the other weird thing of metal and metallic. You leave that. The real metallic bond is here. A metal alone must lose electrons to form positive ion. So we have two things, electrons being lost and the positive ion being formed. The ion is positive, electrons are negative, so they can attract themselves. So That force of attraction is what they call a metallic bond because it is connecting two things that have come from metals. These electrons have come from what? The metal. The positive ion is of the metal. So the bond is connecting two things coming from metal. That's why we call it a metallic what? A metallic bond. I don't know if I really had that one student who knew that that is a metallic bond. Hey, yeah. Hey, you are good students. That is nice. That is nice. Maybe you will even make better doctors because for you have known it a bit earlier than I did. Yeah. So, um, you have seen the structure of metallic bond, the real one, the real one. So, what if we want to come up with a complex structure of those metal atoms? Or what if I say that we just want to come up with a complex structure? Just complex structure. And I stop there. Complex structure. So you people have realized, that we shall have this M with the plus, 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 with the plus. You get the point? And each of these ones is attracting its electron cloud. Each of these ones is attracting its electron cloud. This one is attracting its electron cloud. This one is attracting its electron cloud. Yes, this one is attracting its electron cloud. This one is attracting its electron cloud. This one is attracting its electron cloud. You get the point. Now, because of there are a lot of attractions, you all know every time the ion from a metal attracts the electron cloud still from the metal, you come up with a bond, a force that is attracting two things that come from metals. And that's why we call it a metallic bond. So here we come up with a complex structure of metallic bonds. And that's what they call the giant metallic structure. So I don't want you to be calling it just metallic structure. There you'll be a very bad student. I've showed you the structure of the metallic bonds, and I've told you what if we want to come up with a metallic structure, or what if we are having so many atoms around, each of those atoms will lose its electron cloud and it will become a positive ion, and there will be that temporary force of attraction between the two. Why is that attraction exiting? Because they are oppositely charged. So what if these attractions are so many, you come up with a complex structure of metallic bonds, and the structure we come up with is what they call the giant metallic structure. So you people have it in mind. The word metallic bond in your answers, the word metallic bond is a marking point. That's why I've wasted a lot of time on it. The word metallic bond alone is a very important marking point. And the other marking point is about the giant metallic structure. Sometimes they can even get annoyed. They mark giant alone and metallic alone. But that used to happen in the old curriculum. But even in the new curriculum, it may be worth it because giant has a point, even metallic has a point, and it's a complex structure. So, before I go to the non-metals, because they also have their own story. Yes, non-metals also have their own stories and a serious one. So before I go to the bonding and structure for the non-metals, are you okay with what I've done with metals? Should we proceed? Should we proceed and talk about the non-metals? Should we proceed and talk about the non-metals? Should we proceed and talk about the non-metals? What are people saying? Okay, so you're supposed to use that knowledge in other things you find in the future for you to enjoy. Let me hear from Akrod as I explain non-metals. Yes, Akrod.
Yes, thanks, teacher. Teacher, for me,
Mm-mm-mm.
I was like, for me, I knew that that force of attraction between the positive and negative is the electrostatic force of attraction.
Oh, so have you learned something new today?
Yeah.
That is very good. Okay, now non-metals. These ones are very funny. Non-metals. Non-metals. So non-metals, you all know that when you have a non-metal here and a non-metal here, that bond that is between a non-metal and a non-metal is what they call a covalent. Is what they call a covalent bond. Yes, it is a covalent, covalent bond, non-metal and non-metal. So that is done, and that word is very high yield. It's a very important mark in this topic. So I also come and say, what if what if we want complex structures? What if we want complex structures? What if we want complex structures? So I want you people to look at this. You can have here carbon, you can have here chlorine. I want you to get the point. You all know that this carbon is stable with 4 bonds. You get the point? Then we know that since chlorine is in group 7, how many bonds does chlorine need? Let me see those who were attentive in the lesson of alkyl halides. How many bonds do you think chlorine needs to just be happy? When you give maybe chlorine a certain number of bonds, it is happy and it's saying no more. People are saying 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. So which is which? Yeah, it is 1. Thank you, people. Thank you, thank you, thank you, thank you. Yeah, so chlorine needs only 1. I want you to follow. Chlorine needs only 1, like that. Isn't it? Just that. Then this carbon needs 4 of them. So when we put here carbon and we put here carbon, we put here carbon and we put here carbon, we are making matters worse because even this one, we will need more 4, like that. You get the point? Yes, need here carbon, need here carbon, we need here carbon. But even all these ones, even this one needs more 4. Carbon, carbon. You get the point? Even this one will need more 4. Carbon, carbon, and carbon. Uh, uh, uh. Carbon. Even this one will need more 3. Even this one will need more 3. Even this one will need more, 2. Even this one will need more, 2. Even this one will need more, 2. And when I keep on adding carbon, it's going to be worse and worse. Are you following? So you realize this one is endless. So when you look at this structure, it is endless. So I would say, so when you look at that structure, it is an endless network of covalent bonds. It is an endless network. It is an endless network of covalent bonds. Isn't it? Because it will not end. When you put here carbon, it also need more 3. When you put here another carbon, it will also need more what? More 3. This one already needs more 3. So it will just proceed and proceed and proceed. That's what they call an endless network. Yes, remember carbon, someone may be like, but I thought carbon is a metalloid because it is in group 4. But it has more non-metallic properties than metallic properties. That means the non-metallic character dominates. And when it dominates, we treat it as a non-metal. So this is a non-metal and this is a non-metal. So it makes that bond between the two carbon atoms covalent. And when you realize the bonds are endless, it becomes an endless network of covalent bonds, and we shall see how we name it. Yes, we shall see how we name it. Okay. Now, when you look at that chlorine, I remember teaching people in alkenes and alkanes and alkynes. I taught you the bonding and structure. I don't know if people can recall that. But I told you when you're having your chlorine somewhere, now this is what they call the chlorine as a gas, the Cl2. That's how it looks like. So you can be having another Cl2 here, hiding. Yes, you can have another Cl2 here. You can have another Cl2 here, Cl with the bond, then Cl. You get the point? Then you can also have another Cl2 here. Yes, you can have Cl with the bond, then Cl. So you can have another Cl2 here, like that. I want you to follow. So you all know that this is what they call a covalent bond. And I told you that covalent what? Covalent bond. This one said is a covalent bond. So everywhere, covalent bond, covalent bond. But these are separate molecules of Cl2. I don't know if you notice that. Hey, chlorine, maybe you get 3 molecules of chlorine gas and put them in some glass tube. That's how they look like. Now, what if they force themselves to interact with each other? Something like this. I think that they're just interacting with each other. Just interacting with each other like that. Even this one can interact with this, no problem. They're just interacting. Dotted lines. Who can tell me the name of those forces? I told you the name of those forces in bonding and structure of alkanes, alkenes, and alkynes. Those who have been with me, what name did we give to those kinds of forces? That you're having a special molecule with covalent bonds within. And then there are those bonds that come and join those atoms together. So we say this one is covalent what? Covalent bond. I don't know, but those people writing in our screen, please leave it. What are people saying in the chat? What are people saying in the chat? People are saying Vander Waals, but you're writing it poorly. You're writing the name poorly. It is okay in science, they will mark you. They will mark you. They will mark you. But I remember telling you how best you should write that word Vander Waal. Who recalls? Who recalls what I said? Who can raise up their hand and tell me what I said about how Vander Waals is written? Okay, let me hear from Judith. Yes, Judith. I think Judith is silent. Yes, iPhone. Say something. But how can someone unmute and don't speak? You people just have bad manners. Okay. Where were we? Okay. So these ones, those ones, those ones are what they call Van der Waals. Yes, from today I want you to write it like this. And I want you to give your teacher this reason. You write V as small, you write D as small, but write this W as capital. Yes, yes, capital. But these ones are small letters. So they are called Van der Waals, forces of attraction. You can just say Van der Waals forces, can complete whatever you want. So I'm going to just tell you some sort of story, a simple one about the Van der Waals. So in Islam there is what they call I remember I used to study IRE very many years back, like 13 years back. We used to study Abakari. Then we used to say Abakari bin Affan. Was it Uthman bin Affan? Something like that. And they used to tell us that the word bin means son of. So when they say Abakari bin Affan, they mean Abakari, the son of Affan, something like that. I don't know if it means daughter. I don't know if it also means daughter, but I only remember son. But if it also means daughter, so we can have something like this. Women being Satan. That's if bin also means daughter, then that statement is also correct. But if bin is only for sons, then it may not work. But women being Satan can also work if at all bin is also right for daughters. So Van der Waals, it is for the Dutch, those people. I don't know their country, but it means of the. So this Waals was a family. Yeah, you get that in a textbook called a comprehensive chemistry. So Waals was the family for those guys. And the scientist was called Johannes Diderik van der Waals. That was the name of the scientist. Yes. So the scientist, let me teach you something today. At least you know the scientist. He was called Johannes Diderik. Johannes Diderik van der Waals. You get? So this Vander means of the. So the scientist was called Johannes Diderik, and he was of the Waals family. So Waals was a family. So I want you to disturb all of us, your tutors. Small v, small d, capital W. Why? Vander means of the, and the scientist was Johannes Diderik of the Waals family, or Johannes Diderik Vander Waals. Yes, and that's why they call them like that. So back to the chemistry. What is the essence of all that? What is the essence of all that? What is the essence of all that? So this network of purely strong covalent bonds, they are strong. You know that. It is a strong network. Strong network. Strong network. Strong network. Then when I come here to this, the Vander Waals, everyone knows that these ones are weak. A weak network. You understand? The other network was endless and with covalent bonds only, so it was strong. But this network was dominated by Vander Waals forces, which are weak. So this, for this network, is a weak one. It is a weak network. I want you to listen. Weak network. So both of them, I want you to understand that they are covalent structures. All of them, or both of them. The first one is a covalent structure because both of them have covalent bonds within. Even this next one, which has the Vander Waals within it, is also a covalent what? Structure. I want you to listen. The other word to mean covalent, or before I even tell you that. Because here we have purely covalent bonds and the network being formed is a strong one. And that network is endless. That means it can become bigger and bigger and bigger and bigger. So it becomes giant. So the structure is called giant covalent structure. I'm coming to molecular, don't worry. So the structure is what? Giant. For reasons I've said. Why giant? It's endless. And that network of covalent bonds we are forming is a strong one. Here where we have a very weak network, and this network of Van der Waals forces is not even endless. No need of even making it endless. After all, the network is weak. So it should have a limit, because even if you make it endless, you will have done nothing. It remains weak. And since for it is weak, the structure cannot be giant. The structure is just a simple one. So since here we have a weak network formed by covalent bonds, for us we shall have a simple structure that is covalent. So this side we are coming up with the giant covalent structure, then this side we are coming up with the simple covalent structure. But the other word for covalent is molecular. The other word, covalent, is molecular. So it can be giant molecular structure. I've said the other word for covalent is molecular. So we can have simple molecular structure, simple covalent structure, giant covalent structure, giant molecular structure. And I've showed you how those structures are coming about. Trust me, when you understand this structure and bonding, these simple things, with time, these things will make sense and they will not disturb you at all. But if at all the basics are disturbing, even the near future will be very bad at your side. So these are things you're supposed to appreciate as early as this. So I don't know if people are with me. Are we on the same page as far as Van der Waals are concerned, or as far as bonding and structure in nonmetals is concerned? Are we together? Are we together? Hey, all of you failed Vander Waals. Hey, daughter is bint. Hey, so it is women bint Saturn. Yeah, that is nice. Aha, you people are funny. You people are funny. Hey, by the way, you take the comment section of the Zoom lessons serious, because I can see there is a conversation that Eric Sairi is coming up with the Mary. Yes, and that's how you say on your wedding. Hey, Mary will be saying, I also found Eric in the Zoom comment section of Dr. Paul. You see? So on top of the A of chemistry, you will have gotten a man who will be willing to cheat on you for the rest of his life. Yeah. So we go to our notes and see how far we've gone. So bonding and structure. Very fast, let us see if we are on the same page before we go to other things. So we are going to come here and say bonding and what? Bonding and structure. We have the element and the symbol. Those ones are obvious. Now about the bonding, all these ones are metals. I didn't bother to tell you what metals are because I said that when I was teaching the periodic table. Showed you metals, metalloids and everything. I don't usually repeat myself. That's why I ask you to make notes out of these video lessons, so that your role is to afterwards revisit the notes and not rewatching the video. Hey. So, because they are metals, they are telling you that the bonding that exists between metals is metallic. And you know what metallic bonds are. And the complex structure that comes about, it is a giant structure of metallic bonds. So, giant metallic structure. Oh, these ones are non-metals. Because they are non-metals, the bonding there is covalent. Silicon, that one will give you a giant covalent structure. You've seen how it comes about. You know silicon is also in group 4 like carbon. You get? So also silicon, since it is in the same group as carbon, you see what will happen? Silicon will come here, silicon will come here. Silicon will go there, silicon will go there. And again, this one will need to make up for. Even this one will need for even this one, like that. So it will keep on going and going. It will be an endless structure of covalent what? Bonds. And it will turn out to be a giant one. And that one is so common with those ones of group 4 because for them they have 4 bonds. So they just go on and on and on and on like that. But these other ones of phosphorus, the example I gave was that of chlorine. The example I gave was that of chlorine. But you can also do your own, that is having sulfur, phosphorus, and what? Argon. And simple molecular. And you people know that simple molecular is related to Van der Waals forces of attraction, where our scientist is Johannes Diderik van der Waals, the Waals family of the Dutch. Yeah. Now, bonding and structure is done. So I'll go to our notes. Where are they? And I'll tick bonding and structure as well. So if you're there and think we are not moving, for us we are moving. Hey, we are moving and we are getting done. That one is done. So for periodic properties and periodicity, if you look at the syllabus book, you look at them. The things they want are these things of melting points. I want you to look at this. Someone may be like, but doctor, you are not teaching these things, yet we actually need them. But that's not the whole point. I want to remove this and show you something so that you don't call me a bad person. I don't want you to call me a bad person. So you look here. You look here. So when you look at part D, Then also here we are having a part A. So here they said atomic radius. Even here under period 3 they said atomic radius. Ionic radius, even here ionic radius. First ionization energy, even here first ionization energy. First electron affinity, even here first electron affinity. Electronegativity, even here electronegativity. Electropositivity, even here electro what? Positivity. The only thing that we have in period 3, and it wasn't in periodicity 1, it is what? Melting point. So the only thing that you actually demand me here is melting point. I don't know if people are getting me. So it's like everything you need is there, apart from melting point and graphical data. I just hinted something small about graphs in periodicity, and I usually do graphs in revision. Yes, that's what I usually do. So literally 90% of the part A is already there in periodicity. We are talking about both across a period and down a group. You're supposed to make a lot of notes and take screenshots because the notes I used in that session, they were very good and I was adding in a lot of words. So you have to sit down and make sure you understand those things. Make sure they connect and make sense. Hey, okay. So as I come to the next, where are we? Where we are here. Okay. I really want to do reactions. Reactions are my best things in chemistry. Best. That's what I like most. Why do I like equations most? Because they are the ones that give students the most hard time. And they were simplest for me back then. Yes. Back then, 11 years back, I was in senior 5. And they were just easy. So I wanted to brief you about what we are going to do. So we are going to come here and write and say, we're going to write and say that concerning, this is C. So concerning some of you are going to graduate and become teachers, and you come back to me to pay for the drive. But I think I will have changed. I think I will have changed. My passion for education will have ceased. But I don't know what God will decide. So concerning the periodic properties and their periodicity, I'm going to give you the direction, the sense of direction. Hey, so concerning periodic properties and periodicity, I'll say that concerning periodic properties, and periodicity, refer to concerning periodic properties and periodicity, refer to the two lessons under the periodic table. Under the periodic table, the topic is called the periodic table. Under periodic table, in the topic of periodicity 1, and it is topic 4. So you find all those things. Periodicity 1, and this one is under senior 5. I think we say term to work. Yeah, senior 5, term to work. Yeah, you enjoy. You go and what? You go and enjoy. Under periodic table, topic 4, periodicity 1 and a term 2 work. Yeah. Basically, that's how I'm not repeating. So what are those things that I'm supposed to do? So after going through, them, for us we shall handle melting points. We shall handle melting points and graphical periodicity in revision. Yeah, and you should be taking these things. You should be taking note of these things so that when you see UNEB coming nearer and nearer, yet we have not yet revised what I promised to revise, have it in mind that that's what is coming. And I also write this down so that if at your school you officially revise this thing, that means there is no need of even looking for the recording where I revised them from, because you'll have perfected them from school. I give them to you because they are examination high yields. So we shall handle melting points and graphical periodicity. Graphical periodicity, I mean, when the periodicity decided to be tabulated and asked to plot a graph describing the shape and explaining the shape. That's what I mean by graphical periodicity. Yes, praise Cowton. What are you saying?
Good evening, Doctor.
Yes, please.
And other fellow members. Doctor, I've been saying that people in the chat are requesting to take screenshots.
Oh, thank you. You see, I told you that I need a chat secretary, but people just keep. I don't always look there. Yes, I only go there when I pause a bit. So from which page? From the first one. Okay, I'm giving you just a second per screenshot. So that one, you're done. You take that one, you're also done. Okay, you take that one, you're also done. So we can proceed here. Okay, so that is our plan. So for periodicity, we have our lesson targets. You should make sure we follow them up very well. So when I go back to the very first page, I'm also going to put a tick on this because I've given you the sense of direction. I'll put those ticks, even graphical work, you know where it's supposed to be. For you, collect the content. Revision will be very nice. Yeah. It will be very nice. Yeah. So for periodicity that is graphical and melting points, I've not told you to research. Don't research. But when you research, you will understand because melting points depend on bonding and structure, which I've explained. Then for these other physical properties, the physical states and density, those ones you're supposed to do them on your own. You know me, I don't usually do those things because the internet has the best work. Go to internet, put in physical properties of period elements, physical states, density. Make research, make your sample notes, proceed. So those ones are going to be your research works. And for me, there and then I'll jump to the chemical properties. Yes. So the only thing I've left out are melting points and graphical periodicity. Others I've covered. And I cannot leave a lesson without research work, without assignments. Should be kept busy. Your candidates. So research work about the physical states. But you people, you look at this form of research work. Just physical states and density. Your friends are making their own notes of the full topic and they are presenting in class. For you, I've only asked you for physical states and density. Something very small. You can even do it online. Make research, copy and paste as you usually do. Physical states and density of period 3 elements. Make research. Why I want you to make research on such things? Because they are the ones that will make sense in application. And at a level, you just want to pass and go away. Yes, physical states, know them, know the density. Know the density of aluminium and how it is actually applied in use of aluminium in maybe in the industries that make the different parts of aircrafts. Such things, I don't always want to go there because internet usually brings them out so well and no reasoning is needed. Get the point? Yeah. So finally, we shall have our heading, which is chemical properties, chemical properties, and have it in mind. Chemical properties are the same as chemical reactions. Chemical properties are the same as chemical reactions. Chemical reactions of period 3 elements. Yeah. So we are beginning with elements. Remember we said elements, oxides and chlorides. But of course elements first, then the rest follow. Because oxides come when elements react with oxygen, then chlorides come when these elements react with what? With chlorine. Yeah, it's always best when we concentrate on those reactions that they asked us to do. Yeah. But before I go to these reactions, I'm going to give you a minute for just to think about what we've done. You comment about how far we have moved, whether the lesson is so far cool and you're ready for us to go into phase 2 of the lesson, which are the chemical properties. Any questions if you have, any concerns, any suggestions, any advice, any form of complimentary suggestions and improvements, anything. Just a minute. And you also relax a bit, breathe in and out, take some water. If you're having your food, you can eat a bit, then we proceed because we are beginning the chemistry. And if you missed the lesson of chemical properties, of chemical equations, you may find some hard time here. So when you find that hard time, task yourself of visiting that work first before you can come back here and master it. So meanwhile, you'll be learning by heart, appreciating the flow of content, and the rest will come later. Hope that is okay. So then, just a minute. I've been trying to go through the messages in the chat. But people are just used to quarreling. Yeah, but you ignore all that. Anyway, hey people, why can't you leave my screen? Please, those people who have put those things in the screen, please remove them. I don't want it to be weird. That is very bad. So we are going to look at the chemical properties of elements. We are going to look at them. The syllabus wants us to talk about water. We shall not leave water. And after water, we are supposed to talk about the dilute acids. And we should also not forget the dilute acids. They are concentrated ones, but the syllabus doesn't mention it. That means we may be safe from them. Then the syllabus says dilute acids and alkalis, and I try to tell you something about that. Ariho, did you want to say something? Your hand is now down. So we are now going to look at these reactions and see. Yeah, I want us to complete those of elements. Then maybe next time shall do oxides. Then I think in the morning. In the morning there is no lesson. No, you were supposed to visit the drive, but I may teach in the morning, so don't be surprised. So we want to talk about the reactions for basically only the elements, so that people don't burst from here. Then next time we shall do the oxides alone. Get the point? Then chlorides the next time. I think we shall combine oxides and chlorides in the same lesson. I think that will work because oxides are not much. They are not much, and they only want water, acids, and sodium hydroxide. Then we shall look at the chlorides also, and we shall be done. The other things of qualitative analysis, they won't matter. In the previous curriculum, people had to cover hydrides. Yes, and they had to cover qualitative analysis for all the ions. But for us, we are only doing oxides, chlorides, and only magnesium and aluminium, then diagonal relationships. So you can decide to teach period 3 in 3 lessons only. Yes, I can decide to do. Today, I do all chemical properties or reactions for the elements. Next time, I do chlorides and what? And oxides. Very possible. Then the other time, I do diagonal relationship and the qualitative analysis of the two ions. Very possible. And that's the plan I prefer. Why I'm not on pressure? Group 14 and group 17, they're already on the drive. They're already there, and I'm never repeating myself. Go there. Most of you are complaining. Let me use this opportunity to say this here. I want you people to be genuine in the chat. When I gave people work in the morning and the work was already recorded, it was work for normal distribution. Some people were complaining. They were like, for us, we want live lessons. We don't want already recorded work. You people, one of our main goals is to complete the syllabus before you enter senior 6. Do you people think that the holidays, which are just 1 month, you spend 3 months at school and you have holidays of 1 month, sometimes 3 weeks, some schools 2 weeks. This second term holiday, some schools are going back mid-January, meaning the holiday is just a month and a half. But remember, you have Christmas season, so it approximates to a month. So do you expect us to cover work in just 3 months of holiday? So I'm supposed to always record work before you come so that you find that work recorded. But someone was like, for me, I'm not following, the things are not flowing because the work was recorded long time. For you don't imagine about the people who were commenting that time. For you concentrate on me who is teaching and follow what I'm saying. Period. And most of those lessons were not so interactive. So you just follow what I'm doing. So I want you people to tell me in the chat. What you tell me is what I would do. Do you really want us to depend on these lessons only for the new work? Meaning we are not even supposed to have a drive. If you don't attend lively, you miss it. People were like, that work is not good. According to me, it is necessary. Like you have there 9 lessons of integration. Even look for your own time, convenience, and pace to watch that work. So why do you say it is unfair? Because it is an old video which was recorded with other students. There were also students like you. So they represented you at that time. So concentrate on the tutor. Where you get confused, take a screenshot and ask. But in most cases, those concepts were given time. And the questions that you would ask were asked by some of those students. So the work flows. You don't need to complain that way you just want live lessons each and every time. That one cannot happen. We cannot complete that way. Like for me, I'm assuming in the morning you watched all those videos and completed them. But again, if I would, do you want me to repeat normal distribution? Is it really fair? Not. So, what's your suggestion about that? Should we stick to live lessons and leave the drive alone? Or we should have that already recorded work and you watch at your convenience, even when it was recorded 10 years back? What do you prefer? What do you prefer? In the little time you have, remember Christmas season is coming and most of you won't want to study. But you don't want to see that. You don't want to listen to us who have the experience. For you just want to do things according to your understanding, which has not helped any student in the country. So please listen to us. Do what we tell you. We've been there. Students have listened to us and they have passed. So don't take anything always in bad faith. Just see the good in it and take it on. And let me tell you, most people depend on the drive and not even these live lessons. Some of them come here and doze, and in the end, they will have to revisit work. So please, just follow. Just listen to me. Just listen to me. Now, next year, this work is going to be on the app. Our app is coming, so the drive will be no more. What will you tell me? If I have the work already on the app, then what do you want me to what do you want me to do and what do you want me to tell you? Yeah, so that is it. So the syllabus wants us to only and only look at reactions of water, dilute acids, and alkalis, as I told you. But again, the same syllabus books want us to do oxides and chlorides, which chlorides come as a result of the elements reacting with oxygen and chlorine. I don't know if people are getting me. It wants us to react elements with only three things: water, dilute acids, and alkalis. But again, it is telling us to cover oxides and chlorides, which come as a result of elements reacting with oxygen and chlorine. That means we are going to fix those reactions by force. That means we are going to fix those reactions by what? By force. So, I've said that the syllabus book so elements, they want us to react them with water. They want us to react them with dilute acids. They want us to react them with what? Alkalis, only that. But again, they want us to teach oxides. They want us to teach oxides after elements. But remember, oxides come as a result of these elements reacting with oxygen. So I'll just say air. So basically, air has the oxygen, air has the what? The nitrogen. After oxides, so when they react with oxygen, what we form are the oxides, and they want us to teach oxides. So don't be like, why are you including reactions which are not on the syllabus? That is why. Then they also want us to teach chlorides. So we shall need to find out how elements react with what? With chlorine. Yes. And what happens after that is we form what? Form chlorides. So we shall fix those two reactions on top of these ones of water, dilute acids, and alkalis. Hope that adjustment is fine. Okay, so you can take the screenshot because I know you need it. That is the screenshot. So you can take it. Yeah, of course, people will need both. I've not said that all work was recorded. That's why you see some folders empty. Why they are empty? Because those ones are reserved for the live what classes. But we always also have that already recorded work. So the best answer is that both are necessary. Both are necessary. That is it. So I think we can start. I remember when I was teaching you chemical equations, I talked of combustion reactions. I talked of combustion reactions. Yeah, combustion reactions, which were reactions with oxygen. Yeah. It's reactions with oxygen. So I can first say air. Yeah, but I've said air basically it is oxygen and nitrogen. Yeah. So you should know those things. So remember telling people, I told you equations that if it is sodium, you need to know that sodium exists as a what? A solid. Remember we are talking of elements of period 3, and sodium is the very first element of period 3. So it must react with oxygen like that. You know oxygen looks like that. So the question should be, what is the product we are forming? Most of you have issues with these reactions, but please visit that lesson I've told you. So you should know why this one is S. You should know why this one is D. Oxygen is a gas and sodium is a metal. So metals are solids. Oxygen is a gas. So what is this format formed, or what is formed? So we're having Na and O. It is the atoms that form the compounds. So sodium has a valence 1, but O has a valency of 2. You get the point? So this one comes here, this one goes there. I don't know if people recall that it is atoms that form the compounds. You get the point? Sodium atom, oxygen atom. The valencies are put on top. I remember explaining to you very well what the word valency means. We actually gave that first holiday time and serious basics were taught. So you can realize that what comes from here is Na2 with O. So you also come and write it Na2 with the O. Now that one cannot be a gas. It does not even which gas is that? It cannot be a liquid because most liquids are known. It is a metal and you've passed a gas over it. So even these final steps usually disturb people, but just ask yourself, you're having a solid and a gas, and you're bringing them together. What is the likely product? You're just getting this gas and you're passing it over a solid. Chances are high that you're just going to change the chemical nature of the solid and the gas will just pass by. So you're remaining with the solid still. Get the point? So you should first respect or prioritize you having the correct formula. Then you prioritize you having the correct state. Then lastly, the balancing. I remember telling you that. That these equations are always 1.5 marks. A half for the structure, a half for the states, then the other half for the balancing. But if you don't balance, you lose all the marks. You lose all the marks. So someone may be like, what can I really do with this balancing? I taught you balancing. If you have issues, please visit it. But this one is easy. How? Here oxygens are 2, but here oxygen is 1. So to make it 2, 2, I'll put here a 2. But putting there a 2 makes sodium to be a 4. And this side sodium is 1. So you put there a 4. And the whole equation what? Balances. I get my 1.5 marks. So I want someone who is going to tell me that this equation is okay. You know why this is sodium. You know why we have solids. We know why this is oxygen. We know why this is a gas. We know why the structure is like this. We know why it's a solid. And you know why we have a 2 there and a 4 there. I want to see those people in the chat who tell me we are good to go. Are we good to go? Are we good to go? By good to go, I can now write the next element and we see. Is it okay to balance the equation with a half? Very okay. Very okay. If you know how to balance using half, it is accepted in chemistry. It is accepted in chemistry. And I believe by this time, balancing shouldn't be a problem to any of you. Okay, now when I go to magnesium, magnesium is a metal, so it is a solid. Oxygen is a gas, and you all know it is diatomic. Why is it diatomic? I explained all those things long time. What do we form? What do we form? So that goes back to what I've been saying or to what I said. That magnesium and O, it is the atoms that form the compound. Magnesium, it is valency 2 because it is in group 2. Oxygen, it is valency 2 because of group 6. Someone will be like, it is group 6 but valency 2, yes. Because in group 6, it gains 2 electrons to become stable. Then in group 2, it loses 2 electrons to become stable. That's why both of them have the same valence. Valence is simply the number of electrons either shared, lost, or gained. Nothing else. So these 2 will cancel with this. So you can see that magnesium oxide is just like that. So this one is what? MgO. And we said you're just getting a gas and passing it over a heated solid. So what you're forming will also be what? Solid. And if you want to balance, someone said, what if you just, because when you put here a half, it's like this half, these 2 cancel, and remain with only a single O. So you have single O, even this side single O, single M and single M. So that equation is okay and it is balancing and it is acceptable. But what if you want to use the other general things? I also remember telling you that when you put here a half and you don't want fractions, you just multiply by 2. Multiply here by 2, multiply here by 2, you multiply here by what? By 2. But remember, when you multiply a half by 2, it disappears. So you see the new equation. So you either balance with fractions first, then you eliminate them, or you use fractions and leave them, or you use the other normal format. But the normal format is what you get after bringing the fraction and eliminating the fraction. You get that? Imagine if I didn't have the fraction, I would be like, these oxygens are 2, but this side I have 1, so you put a 2 here. But this 2 makes magnesium 2, so you also put here 2 on magnesium, and you get your 1.5 what? Max. But even when you had brought the half first, and you'd be like, magnesium is already 1. If I put here O, so if I put here half, even O will be 1, because it's like that a half cancels that 2 on oxygen. So that means to eliminate their half, it will be like mathematics. I multiply here by 2, I multiply here by 2, I multiply here by 2. But a half by 2, everything disappears. So the normal thing is what you get when you bring a fraction and eliminate it. But you can bring a fraction and actually leave it there. Hope we are together. So others, I think you can come up with them. I believe you can do that. I believe you can do that. So I just want to say something about these ones. Yeah. Those ones you all know are metals, and they must be heated for them to react. Heated is very important. So the heated part is the condition for the reaction. So when they ask you for the condition of that reaction is that the metals participating, they should do what? They should be heated for the reaction to proceed very nicely. So concerning the names, I told you these names. Yeah, I told you that that first one is sodium oxide, and there are two names. Sodium, then oxide. Two names, separate. Even this one is magnesium oxide, two separate names. So, you people, that is it concerning reactions with oxygen. With air, but air has oxygen and nitrogen. So what if someone wants to really consider nitrogen also? You just need to know who exactly reacts with nitrogen. You see this inorganic chemistry, you can read and be understanding. But my dear, retaining it is the hardest part. Hey, retaining equations is hard. So you need to note that the magnesium and aluminium are the best friends of nitrogen. So if at all we are talking of reactions with air, it's them that may be interested in what? In the nitrogen. So those two are the best friends of what? Of nitrogen. I've told you that this inorganic chemistry, they can explain to you and understand. You can read and understand. But retaining these equations is now the hardest thing. So don't think that after here you're going to just sit back and relax. My dear, no. If that is one of your plans, you're going to flop. You're going to flop. You need to know what reacts when and what reacts where. You need to know those things. You need to know those things. And for us, we are going to do our best and cover them right now. Then in your free time, you will struggle. Hey, you will struggle. Now, assuming you're having your magnesium like this, you all know that the metals must be heated. Yeah. For this air, they always talk of excess, they talk of limited, and so on and so forth. But don't mind so much about that. We are going to hint about everything. So if it is magnesium is solid, and you're having your nitrogen, which is a gas, so what do you get? So you all know you're having magnesium, you're having N. Magnesium is valency 2, then nitrogen is valence what? 3. Why valency 3? It is in group 5, according to the periodic table. Then magnesium, why valency 2? It is what? It is in group 2. So that 2 goes there, this one goes here. Get the point? And the structure we form is Mg3N2, and it is also solid for the same reasons. Now this one was very easy. This one is N2, even this is N2. So the nitrogen is okay. But here magnesium is 1, but here there are 3. So I come and put here what? A 3. And you're done. And you're done. All marks bagged. And nothing has been done. But you're not supposed to forget that this one should be what? Heated. Because if you don't heat it, the reaction will not proceed. It is a condition for that reaction to occur. So you need to know all those things. Hey, you need to know those things. If it is now aluminium, you know what to do. Aluminium has valency 3, even nitrogen has valency 3. So you don't supposed to be surprised when you find aluminium nitride being written like that. Because aluminium had valency 3, even this N had valency 3. So chances are high that they did what? They cancelled. This one cancelled and this one cancelled. Then you came up with that. Yeah. So when you find such structures, just don't be bothered. Balancing becomes very easy. Put a 2 on aluminium nitride, put a 2 on aluminium, and you're good to go. Now, This oxygen can Isaac, but this is the reaction used to cover in O level. Yes, just want to talk about air in a sketchy way. So, there is when you get this sodium and you react it with oxygen gas, and maybe when this oxygen gas is in excess, and then you get what they call sodium peroxide. So sodium peroxide, sodium is like that, the peroxide looks like this. Yes, sodium has valence 1, the peroxide has a valence 2. So when this one comes here, of course one going there causes no issue. So you get the sodium peroxide. Yeah. Same knowledge, this one will be a solid. Oxygen is already 2, oxygen is already 2. But when I put a 2 before sodium, that's when sodium also what? Balances. And then you get your 1.5 marks for the sodium peroxide. Not forgetting that the sodium metal must be what? Heated. And also for this case, if at all you want a peroxide, if you want a peroxide, that oxygen must be in excess. If it is not excess and just normal amounts, it is oxide. The moment the oxygen is too much, the peroxides come in. Not forgetting the heated what? The heated part. A. Where we have cancelling, where we have mathematics in these structures, you should also be well conversant. In period 3, we have silicon somewhere. So silicon is like that. It's having O here, we are having 2 here. The valency of silicon is 4. You get the point? It is 4 because it is in group 4. So the math I meant is this, that by 2, 1. By 2, it is a 2. So this one will give us SiO2 like that. SiO2. I think how it looks like. Hey. Now, because here silicon used the valency of 4, you can always call the product silicon what? 4 oxide. Why silicon 4 oxide? Because it used the valency of 4. You realize when you reach group 14 that these things can have either a valency of 4 or valency of 2. And that's what they call, the phenomenon is called, I'm forgetting the name, but it's called inert pair effect, where you talk about the stability of either the valency 2 or the valency 4. If not that, you can use the normal chemistry. You people know, someone can say silicon dioxide. Just like the way you say that this is carbon dioxide. You understand? CO2. You can also call it carbon 4 oxide. If not carbon 4 oxide, you say carbon dioxide. So I can also say silicon. I leave some space and say what? Dioxide, like that. Both names are okay. How they react: silicon, heat it a bit, bring your oxygen, form what you want. Period. The other special thing is about phosphorus. It's about phosphorus. Phosphorus also usually gives people hard time. So before I talk about phosphorus, you can take that screenshot. Yes, having some reactions with air and some good important hints. So you're going to go through air. I think I'm also I'll talk about the chlorine later. We go through the water. We go through the acids. These things are very hard, but you're supposed to go back and read these things on your own. You can understand everything, but you retaining this work. You can understand all equations as they are explained, but you sitting down and repeating them, trying to master them, that is the dark side of inorganic chemistry. So don't think it's done. It's not actually done. Have it in mind, we have just started. So there is something special about this phosphorus. Yes, and I told you that in more concept, I'm just going to emphasize the point and make it stronger. So I remember teaching you things like diatomic, monoatomic, tetraatomic, triatomic, those things. So I told you that, so I would just ask you to recall. Yes, just please and please recall, because I believe it was mentioned. So I want you to recall that phosphorus. I want you to recall that phosphorus is tetraatomic. Phosphorus is tetraatomic. So at L level, because you're now mature, at L level, when you write P is wrong, but when you write P4, it is right. So P is wrong, P4 is that, of course, for phosphorus. That's what we are talking about, the one that is tetraatomic. So I don't want you to be doing I don't want you to be doing any reaction and you write anything weird. But now the problem usually comes when you react it with oxygen. What is going to happen? That's where problems usually arise. People usually find it hard, but it is a very simple game. Very simple game. So when you're having P4 like that, so someone can be like, but what is this phosphorus? What is the state of phosphorus? Someone maybe who can tell me in the chat, what is the state of phosphorus? Is it a gas? Is it a liquid? Is it a solid? And why? Yes, someone tell us, and why? Yeah, people have passed it. Solid. So you're supposed to know that in most cases it is a solid. Someone will be like, why solid? It's a powder. In most cases we shall find it as a powder, just like sulfur powder. Now note, the other thing that I want you to note, that phosphorus is like that. So being like that, that means it is 2 to 8 to 15, sorry, to 5. Its atomic number is 15, so it is 2 to 8 to 5. Now, because it is ending in 5, it has both valences. It has a valence of 3, and it's also having a valency of 5, both of them. Valency of 3 and valency of 5. So when do we really have the valency of 3? So we have the valency of 3, especially when reacting with limited stuff, reacting with limited oxygen, reacting with limited chlorine, etc. You get the point? So this word limited is very important. Provided it is reacting with limited stuff, that's when it will use a valency of 3. But when it reacts with excess things, it uses a valency of 5. I don't know whether people are getting it. When it is reacting with limited things, it uses a valency of 3. But when those things are in excess, then it will use a valency of what? Valency of 5. So because it is always a powder, we shall give it a what? A solid P4. Why we have this 4 is because phosphorus is tetraatomic. So I think now we can look at some of the reactions and see what to do for everything. Okay. So what if the oxygen we are dealing with is limited? So we have said limited, it will use the limited valency, the 3. So I'll have P4, which is a what? Solid, as you people have said. Shall have our oxygen here, which is our gas, and dash. So you all know that it is atoms which form the products. So this one will be P, this one will be O. So you've said oxygen has a valency of 2, but since it is limited, phosphorus will opt for a valency of what? 3. And you all know what happens. This one goes here, then this one goes here. So the product that you would form is P what? P2 or 3. But to respect this 4, this one, to respect this 4, we shall multiply this one by 2 and also multiply this one by 2. And then we shall come up with P4 or 6 like that. So that by balancing, P is sorted, we just balance. This is O2, this is O6, so we put here 3 and we are done. Yes, like that. This state, I'm going to put it later on. Let me first leave it like that and then take you through the excess oxygen. So what if the oxygen is excess? What if the oxygen is excess? Ready for excess oxygen? The P will always want to take on a valency of what? A valency of 5. So I'll come. So this one is what? P4. Since it is a powder solid, Y4, it exists as a tetraatomic molecule. So I'll have my O2 here. So the question is, what are we getting? You should just have it in mind that in this case, P will use a valency of 5. It's what it will choose. But oxygen has no option other than that valency. Like that. So this 2 goes there. This 5 goes there. And what you get is P, this is 2, this is what? 5. Yeah. So to respect this 4, this one, the tetraatomicity, we shall get this 2, multiply it by 2, also get this 5 and multiply it by what? By 2. And then we shall get another structure, P4 or 10, yeah. So this one of limited oxygen, it will first appear as a liquid. And because oxygen has been limited. So for me, what I understood is that liquid for limited, oxygen, L for limited, L for liquid. And when this oxygen becomes excess, that's when that liquid will finally settle as a what? As a solid like that. The other one was limited, and because of limited, letter L, our first product is a what? A liquid. And when you bring more oxygen, making it excess, you're making it excess. So finally, the liquid will become what? A solid. Remember, you're supposed to respect those physical states because they have a mark at least out of the 1.5. So you fail one physical state, it may take the whole half a mark, which half a mark is very important in chemistry. So that is concerning reactions with air, which are very important. Very important. Now, we people need to understand this. The reactions of water connect us to the reactions of sodium hydroxide. Yes, they do. They connect us to the reactions of sodium hydroxide. And the reactions of water also connect us to the reactions of acids. Someone may be like, what do you mean? What do you mean by that? You people, I had to even teach these things in oxides. You get? Yes, I had to teach these things in oxides because we had to talk about how they are prepared. Even in chlorides, we had to talk about how they are prepared, and this was the way. But it is not necessary. I had to bring them here. So the next thing I'm going to hint about is how chlorides are prepared. Then I tell you what we are going to do for the structure and bonding and melting points for the chlorides and what? And oxides, then I'm going to get that one final lesson. That's the very lesson where I will teach reactions with water, where I will teach reactions with sodium hydroxide. Are you listening? Where I will teach reactions with dilute acids. Sodium hydroxide falls under alkalis, or potassium hydroxide. They are the same things. So hope you people connect. That is the plan. So let's conclude this lesson, and yeah, I think that will work for us. It will work for us, and you also have to find time and go and look through everything. Otherwise, we are almost there. So this is it. So there are those who want to take the screenshot. So I'm also going to talk about the chlorides. Yeah, I'm also going to talk about the chlorides very, very fast. Then I tell you what we are going to do for oxides and chlorides concerning structure and bonding. Then okay. Now, people, let's talk about looked out of reactions of sulfur and chlorine. Oh, just know nothing is different. Yes, but we are going to go to our notes, eh? Don't worry. We're going to go to our notes. But sulfur, that is obvious, eh? Sulfur and oxygen, of course, that is sulfur dioxide. Then for chlorine, chlorine is an oxidizing agent. Eh? So when you react it with oxygen, which is also an oxidizing agent, they may not react. Yes, you may be bringing problems. So chlorine may not react with oxygen at any one point. That's why it's hard for you to find that there is a compound which has both chlorine and oxygen and they are together and are alone with nothing else, because those two are not so friendly when it comes to reacting. But we are going to see that in our notes. I want us to first have general views. You have a look at those things and then, yeah. So let me first talk about the chlorides. So this has been preparations of oxides or how elements react with air. I've briefed you. So let me also talk about the preparation of chlorides. Yes. I told you these reactions are not part of the syllabus, but they want us to teach chlorides. But you should know how they come about. How do they come about? Getting the elements and reacting them with what? With chlorine. So preparation of what? Chlorides. So I don't know if people have realized the balancing of this. That here the P4 is okay, P4. But to make sure that this O10 is the same as this O2, we put here what? Put here 5. Eh? It is obvious. Hey, balancing is easy. So this one won't also be hard because you'll get your sodium, which is a metal. You'll get your Cl2, which is a what? Which is a gas. And you're forming your sodium chloride. Yes, Akrod.
Teacher, excuse me. there
Yes.
on the reactions of phosphorus. What if we keep multiplying by 2 and we just balance?
And we just what?
Balance.
Remember the other, that one is not allowed. We should respect the P4 to maintain that diatomicity. You get? That's the formula
Oh,
in which the compound is stable, and that's what is preferred. So things of balancing with the two outside, the weird formula may not work. The other one is better. Phosphorus must still exist as a ring even in the final product.
okay, sir.
Yeah. So in case you get the sodium and react it with Cl, this is valence 1 and this is valence 1. Why is this one valence 1? Because sodium is in group 1. Why is this one valence 1? Because chlorine is in is in group 7. Group 7, they also have valency 1. So the product is sodium chloride. And you know why it is a solid? Why is it a solid? Because we are simply getting this gas and passing it over this solid. So chances are high that we shall also remain with the what? A solid. So the rule is simple, just like we have been doing things. This sodium must be heated, or some people say hot, others say red hot. Then this chlorine should be dry. Yes, dry chlorine. So when they ask for the conditions, it is dry chlorine and hot or heated sodium. So when you have those two, the reaction can proceed to give you sodium what? Chloride. So these two I've said, they are what they call conditions for the reaction. Those two, they are what they call conditions of what? Condition of the reaction. Yeah. Hot or heated. Then the chlorine should be dry for all the reactions. So how do you balance? It is almost the same thing. I can put here half and I chill. Sodium is 1 on both sides, even Cl is 1. Or I can say Cl is to this side, so to make it to the other side I also put a 2. But this 2 makes sodium 2, so I also put a 2 on sodium. And that's what I prefer. I don't like fractions in equations because there is when they will not work. Yes, fractions don't work every time. Yeah, you should know that. So you should befriend what I also like because I'm your tutor, I'm your mentor. Then magnesium solid, reacting it with what? Chlorine, which is a what? A gas. So the magnesium should be heated as usual, the solid, yeah? And the gas we are bringing, chlorine, should be dry. Should recall that on oxygen, we didn't say anything like dry oxygen, so don't wiseacre. Oxygen, it was just oxygen, apart from a few cases where it was excess, so don't wiseacre. But for chlorine, the condition is clear that it must be dry. So magnesium is in group 2, valency 2. Chlorine is in group 7, so valency 1. So these two will come here. So when that 2 goes there, what will you get? You get Mg, you'll get Mg Cl2 with the what? With the solid. Like that. And this one is balancing. Hope you know why it is a solid. I will not repeat. Then you get your 1.5 marks smartly. When they ask for the conditions, you know. I'm rubbing off these structures, the sketches that help us to come up with the final, because I gave them a time in that lesson of equations. So I don't expect, even in that of chemical formulae. So I don't want to over. I just believe things were very okay. Now, I want to talk about the phosphorus. So phosphorus, this time round, is a bit stubborn because you all know P4 Okay, I want to use the full reaction. So if it is P4, you know it is a solid, and then I bring my chlorine. So you see these things of phosphorus, these ones are powders, as I told you. So the other ones are solids and they are metals. So for them, you should heat them. Remember, even this phosphorus is a solid. So you should also do your best and heat it. Eh? Because it is a powder, it is a solid. For us, we just matter. What we matter about is the solid being heated. But remember, for chlorine, phosphorus, it depends. Are you using limited stuff or you're using excess stuff? So this time round, our chlorine is dry and limited. So those are the conditions. Yes. So when they tell you what are the conditions for the reaction to occur, dry the chlorine, limit the chlorine. If you really want phosphorus to use a valence of 3. Yes. So what did we say about the valence of 3? You know P and Cl. Valence is 3. Listen. And this one is 1. So when this 3 comes, you form PCl5. So someone may be like, sorry, PCl3. So someone may be like, why haven't you put here a 4 and here a 6? So the 4 and 6 work on oxygen. When it comes to Cl, you leave things the way they are. Hey, when it comes to Cl, leave things the way they are. Leave things the way they are. Hey, but when it comes to oxygen, multiply by 2 and match the P4. But when it comes to Cl, leave things the way they are. PCl3, PCl5. How do you balance? So it is very easy. This is P4, but this is only P. So we put here a 4. Chlorine becomes 4 and 3, 12. But this is a 2. How do you make a 2 a 12? By putting a 6. I don't know if people are okay with the balancing. I'm going to put the state later on. So I'm going to proceed. Especially this phosphorus. I know they will have to set it for you if they want you to be confused, but we should clear things now. So in case the phosphorus is given a chance again to react with chlorine, they should make sure that it is heated. That is very important. Then the chlorine they are bringing, they should also make sure that this chlorine is first and foremost dry, and this time round excess. So what do you know about excess chlorine? Phosphorus decides to choose what? A valence of 5. So this time round, if it is 5, we shall come and say PCl 5. This is valence 1, so this 5 will be here. So what you will come up with is the PCl5. Yes, like that. PCl5. So for this thing, for the Cl, leave things the way they are. Don't Isaac by putting P4 smash Cl10. I don't know. May find out putting P4Cl or 20. Very wrong. P4Cl12. Those things are wrong. PCl3, PCl5. When do you have P4O, P4O? In oxygen. P4O6, P4O10. But for PCl5, PCl3, leave things as they are. How do you balance? So, this one is 4. To make it a 4, you also put here. So P becomes P4, P4 on both sides. Cl becomes 20. 4 times 5 is 20. But here it's only a 2. To make it a 20, we put here a 10. I think you see how equations are balancing in chemistry. It is very fun. Then you recall what I said, that when the chlorine is just limited, we shall get our liquid. This L for limited, we shall get this. But when you bring more chlorine, excess, that's when the liquid will solidify. So what we'll get will be S. So someone may be like, but what are you really forming here? In most cases, in chemistry, the colors are, it is very rare to ask observations in L level, but they ask them. But trust me, observations will become easy, even explanations will become easy when you first master the equations, because the equations have more marks. So please and please first master the art of equations. Make sure you can secure the 1.5 marks for each equation. When you later on task yourself and be like, now I'm going to look for colors of all these things in chemistry, it will be easy. You'll be like, the color of this is this, the color of this is this, like that. Be like, these are white fumes, which will be very nice. So don't worry about colors in chemistry. First, make sure you master the art of equations. The rest of the things becomes so easy. They become so easy. And you not need to do anything. Now, there is another special thing. Yes, there is another special thing. It's about, I'd even forgotten. It's about silicon. Now, silicon is a solid. We have our chlorine here, but silicon has a valence of 4. So because of the valence of 4, we shall have Cl. Okay, we shall have something like that, isn't it? So you know why silicon is a solid, you know why chlorine is a gas. You get the point? Si is Si, this is Cl2, but this is Cl4, because silicon has a valence of 4. To balance the Cl, we shall put it to here. Now, the other thing is that silicon tetrachloride is a liquid. That's what I want you to understand. And these are the things that make inorganic chemistry hard. That's why you see people complaining, because maximizing it is very hard. You just look at that page. It is a page for chlorine. But sodium chloride was a solid, magnesium solid, then PCl3 liquid, then PCl5 solid, then again this one else is a liquid. Things now become tough. But you're supposed to just appreciate. A lot of things are supposed to be learnt by heart in inorganic. Yeah. But don't worry. I told you that this silicon is in group 4. If you recall, I told you the silicon is in group 4 or group 14. So let me give you this note. You also find it in the drive or in the folders of group 14. So have it in mind that group 4 or group 14 tetrachlorides. So this is like a rule, yeah? Do you know those things that they say that the first 4 alkanes are gases, the next 7 are liquids, the rest are solids? It's the same thing. So group 4 tetrachlorides are liquids. Yes. And period, nothing else. Group 4, group 14 what? Tetrachlorides are what? Are liquids. So carbon tetrachloride is a liquid. Oh, you look at this periodic table and I show you what I mean. This is group 4. You may be like, what are you meaning, doctor? You're confusing us. What do I mean by group 4 tetrachlorides are liquids? Group 4 is here in red. It is here. So carbon tetrachloride is a liquid. Silicon tetrachloride is a liquid. Germanium tetrachloride is a liquid. Then this one is, what is this SN? People tell me, what is SN? Is it strontium or tin? People were on. Is it strontium or tin? It is tin. Good. Yes. So this is what? Tin 4 chloride or tin tetrachloride is a liquid. Lead 4 chloride or lead tetrachloride is also a liquid. So carbon tetrachloride, silicon tetrachloride, germanium tetrachloride, tin tetrachloride or tin 4 chloride, and then lead 4 chloride or lead tetrachloride. All of them are liquids, and that's what I mean there. Yeah. That's why I saw the chemists are going to become serious and decided and said I'm going to stop somewhere before people freeze from here. We have the time and we shall manage it well. So hope you don't forget that. So lastly, concerning the chlorine, our notes we shall just be perusing through very fast. So lastly is about the sulfur. So we say that sulfur is a powder, making it a solid. But for it to react with chlorine, it should be molten. So the condition for sulfur to react with chlorine is what? Molten sulfur. Are you seeing what makes this inorganic chemistry hard? And it was my favorite branch then because it has a lot of these conditions. And I used to like them so much because I used not to forget. Sulfur, for this case, it is a powder. We expect it to be a solid. But for it to react with chlorine, and you really want it to react with chlorine, you have to first melt it a bit. So when it's molten, you now come and bring your chlorine, which is dry. Yes. So in whatever you're supposed to forget, don't mere forget the dry what? The dry chlorine. Tick. Then the structure formed, the compound formed. Hey, the compound formed. That's what disturbs people a bit. And I'm going to just give it to you. Hey, I don't want you to be like, what is that? So the compound formed is S2Cl2, and it is also a liquid. And time will reach when they will ask you its color. So one of the assignments I'm giving you is to find out the color. You can get the color from textbooks to be on the safest side, but the internet can also help. So the task is you finding out the color of that. Its name is the easiest. You're having two sulfur, so it is disulfur. Then instead of chloride, you have dichloride. I taught you that yesterday. So it is disulfur dichloride. You know if you understand that. It is what? Disulfur dichloride. But what have I said? It should be what? Molten. For it to react with dry what? Chlorine. And those two are what they call conditions for the reaction. What are you forming? S2Cl2, which is also a what? A liquid. The task is its color. What is it? Find out. You get? What is its name? Disulfur. Why disulfur? Because of S2. Dichloride. Why dichloride? Because of the Cl2. How to balance? You already have Cl2 and Cl2. S2 to balance, you put here a 2. And the equation is complete. They give you 1.5 marks. Without struggling. So, after me giving you that overview of the oxides and chlorides and how they are prepared and everything, yeah, I think we can go through the lessons. Yeah, we can go through the lessons. Let me first save our document. Okay, now when I get back here, yeah, that one was done. These ones are going to be done at once. So I've done the most important part of how elements react with oxides and how elements form oxides and chlorides, how they react with oxygen and chlorine. How elements react with oxygen is the preparation of oxides. How elements react with chlorine is the preparation of chlorides. So some important portion has been covered. And I've told you that it is the reaction of water that takes us to the reaction of dilute acids, and it is still the reaction of water that takes us to the reaction of what? Alkalis. And remember, all these reactions should be done for all the three: the oxides, chlorides, and the elements. So that will be done at once, so that I connect for you from water to dilute acids, from water to alkalis. Yes. And of course, alkalis, we shall see the distinction between the dilute and concentrated. So we shall build our work from there. We shall build our work from there, and we shall also come back to this very document and see where exactly the problem is. So maybe we can go through the notes very fast. It will be easy. So concerning the periodicity, this one I told you what you're supposed to do. So I will just put a tick for that because I told you what to do. The graphical work, you can see the tabulations and all these things. They are there in the first lesson. We did all of them because they were the same questions, I guess. So you can see reactions with air. I told you you can use the chance and take a screenshot or later so that you can later follow up. But you can see the sodium hydroxide, you can see the peroxide, you can see the nitride, even here the nitride. You can see this one is a liquid, as I said. You can see strongly heated silicon. Yeah, they are talking of phosphorus burning. You can see the limited supply. You can see heated throughout, as I said. Get that? You can see excess when a peroxide is being formed. So you can go through that work and it will make sense. You get? Even here you can see that if it is excess, they are talking of burning. Yes, they are talking of a white solid. I told you colors are easy, but for you first master the what? The oxides, the equations. So for sulfur, they are talking of heated, and they're also talking of what? Sulfur dioxide. You can see there are two words, as I said, the equation is there. So the other the other sensitive thing I'm seeing is that phosphorus is burning. Here they are using burning, but for chlorine you're going to see that they are using heating. So these are things you're supposed to concentrate on. It'd be like, oh, phosphorus in oxygen we shall be using, it burns. Then in chlorine we shall be using, it's heated. Okay. That's why I told you you're supposed to learn things by heart in this branch. You can see equations making sense, but you sitting down and write them on your own and try to bring them back is very hard. So learn that by heart. In oxygen, phosphorus is burning. Chlorine, the phosphorus is being heated. Have that in mind. So I've told you the reactions of water are the ones that connect to reactions of dilute acids. Someone may be like, but how? It's because this word dilute means water. The word dilute alone means water. So when you understand the reactions of water, you will understand those of dilute what? Acids. You get the point? Yes. And also dilute alkalis, dilute means water. And you cannot understand concentrated without dilute. So it is a sequence. So I've decided to push it. Concentrated ones, they were not stated in your syllabus books. So maybe you people will just have it as research, or you ignore. You ignore until we wait for the elements of construct and see what we shall do. So those who will be listening to this in the future, if concentrated acids won't be part of any element of construct, don't even bother to do it as research. You just simply ignore. All that is concentrated stuff. Yeah. So you can see the chlorine here. Can see magnesium and aluminium up to silicon, they said heated. You understand? They are saying burning sodium. Someone may be like, but here you're saying burning, but the other side they said heated. In chemistry, they will accept the two. Because in most cases, something cannot burn if you've not heated it first. I don't know if you're getting it. In most cases, something should first be heated and then it decides to burn. So burning comes after heating. If you burn something, you're supposed to first provide heat for it to burn. It's like boiling something. If you really want something to boil, or if you want to warm something, you should heat. Like in organic chemistry, those things you say, acidified water and warm, boiled water, such things. If I just put heat, I get my marks, because you cannot boil without heating, you cannot warm without heating, you cannot burn without heating. But the best student goes with those anomalies. Phosphorus burns in oxygen. Phosphorus heated in chlorine. You can see. I think for this case, this is phosphorus. This time around, we are dealing with chlorine, and it's now heated. But before, that was in oxygen, it was just burnt. And when it is limited, you can see PCl3, and it is a liquid. When it is excess, it is the white solid. These are the fumes, which fumes can later condense and become a liquid. You can see for this case it is molten sulfur. You can see sulfur is molten, chlorine is ever dry, that one doesn't change, and you can see the disulfur dichloride, which is also a what? A liquid. And after that, we shall be talking about the oxides. We also talk about that table very well. We shall talk about it, and then I show you the sequence of those reactions. How that of water connects to that of dilute acids, how it connects to that of dilute alkalis. Period. And then we shall see what we can have for the concentrated ones. As simple as that. So, hope you people have the next stop. The next stop. So the next stop is how the reaction of water connects to that of dilute acids, and how the reaction of water connects to that of dilute alkalis. This is reaction of, so you now know the so when I use those chlorides anyway, I don't want you to be confused, because now you know how they are coming about and everything. So next time you are going to just be using them. So we want to see how reactions with water connect. So these arrows mean connect. Connect to those of dilute acids, connect to those of dilute alkalis. And all this is happening for what? For the elements, which you now know very well. For the oxides, which you also now know very well, we have just prepared them. And for the chlorides, which you also know very well, and we have just prepared them. So it will be easy for us, because we shall be knowing what we are dealing with, and we shall know that we are looking for the link reaction between water and dilute acids, and link reaction between water and dilute what? Alkalis. And trust me, we shall enjoy that. Okay, so allow me sign out. Unless you have a concern, you raise it before I go. Sign out as Paul Tutor. I don't know if the many people who are on have been listening. If you have been listening, at least leave a message. I confirm that you have been listening and not dozing. So, I'm a science math tutor. Science Scholars Academy, Uganda. Yes, if you really want to reach out to me, this is the contact. And I prefer WhatsApp calls, but you can text. I prefer WhatsApp calls, but you can text as well. So what is the assignment? You all know I never leave this place without assignment. So the assignment on top of the research work you already have there, and the references, I've referred you to very many videos, but I'll give you an assignment. You practice only the taught equations. Practice only the taught equations and leave the rest for me. Only the taught ones. Practice only the taught what? Practice only the taught equations. That is the final end. Yeah. Otherwise, thank you for attending. I don't know if people need to also take this screenshot. Yeah, thank you for attending, people. You take that. I don't know if you have taken that. So you take that screenshot too. Then I end the class. So you also take that one. It is the last one. You take the assignment serious, please. Take the assignment serious. So let me see what people are saying in the chat. People are dozing. Let me see if someone has prayed for me well. Thank you, doctor. Thanks, doctor. What time is the next lesson? You are not easy. I was told at school that balancing with fractions is only done in physical chemistry. No, it's done in all chemistry. Don't worry. And really appreciate you, sir. Thank you. Dana is my best friend. Teacher timetable. They are going to send it to you. It is everywhere on WhatsApp. Is there a lesson in the morning? Yes. I have put it there for matters of favoring our coverage. Screenshot, I enjoyed to the max, even me I enjoyed. It has been wow, I've been listening. It's a dark orange liquid. Yes, dark orange is okay already. So I thought sulfur is a solid, not a liquid. Yes, it is a solid, but in that reaction, the condition for it to react, it had to be molten. That's why I told you that that's what makes that branch very weird. Yeah, so it's supposed to be sober. Someone is like, in inorganic we use two different names and organic always one name. Organic, it's not always one name. Even in inorganic, it's not always two names. Because in inorganic, as we are naming complexes, it's one name in most cases. And in organic, there is when we have two names. Yes. So you just need to be listening to us. Slowly, like that. Otherwise, you people, bye. We link up tomorrow morning. I will see what I can teach tomorrow morning because I'll be in the mood of teaching, inshallah. Otherwise, bye bye, people.